Find the volume of the solid obtained by rotating the region bounded by y equals tan squared of x times secant squared of x equals pi over 4, and y equals 0. This will be rotated about the x-axis. The graph is provided here for you. We're rotating around the x-axis. So we recognize that the region is flush up against the axis. So let's go ahead and draw a rectangle that's perpendicular to the axis of rotation. And since we see that it's going to be no gap between the region and the axis, we'll go for disk method. And it's going to be an x because the rectangle is upright and it'll be moved from left to right. So the formula for disk just requires us to find the radius and then square it. But here the radius is the distance up to the function tan squared secant squared. So we go and square that, and we go from 0 to pi over 4. When we square tan squared secant squared, we get tan fourth secant fourth. And the attack on that will be the fact that there is an even power of secant. When that's the case, we factor out 2 powers of secant in order to set up the u-substitution. If we go and factor out 2 powers of secant, we'll still be left with 2 powers of secant and also the 4 powers of tangent. Okay. Let's go to the next slide to see how this works itself out. The whole reason why we decided to factor out these 2 powers of secant is so that we can end up with a u-substitution. The function that has secant squared as its derivative is tangent. So these powers of tangent we'll leave alone, but these powers of secant need to be converted into powers of tangent. Well, how do we do that? We transform the remaining powers of secant using the identity that secant squared on x is 1 plus the tan squared on x. So those secant squareds get replaced by 1 plus tan squared. There's only one time we have to do that. But at this point then we're ready to do the u-substitution. Because if we let u be tan x, we'll just be left with some kind of a polynomial that's just in u. And this guy will be the derivative. If u is tangent of x, the derivative is secant squared of x dx. And so we'll be left with just a polynomial integral in u. We'll have u to the 4th times the quantity of 1 plus u squared. We'll distribute that in. We'll have u to the 4th plus u to the 6th. Fundamental theorem of calculus says we just need to find the antiderivative, so we just go u to the power rule in reverse, u to the 5th over 5, and u to the 7th over 7. But don't plug in 0 and power over 4. Those are x numbers, so we'll sub back in for u and replace it with our substitution of tangent of x. We'll have a 5th of tan x to the 5th, a 7th of tan x to the 7th, and we're going from 0 to pi over 4. Now, you know, the tan of pi over 4 is equal to 1, and the tan of 0 is equal to 0. So what's going to happen, these will be 1 to the 5th and 1 to the 7th, which is just 1, and then zeros for the lower limit. So we just really have a 5th and a 7th. Put these two guys together as a common denominator of 35 times by 7 in the first fraction, multiply by 5 in the second, add those 7 and 5 together to give you 12 for a final volume of 12 pi over 35.